Hello everyone. Today I want to talk about delegate in C Sharp. So here we have a function in C Sharp, and the name of the function directly contains the instructions for the whole function. That's why when we use the name of the function, we actually execute the function. But delegate, on the other hand, it references the function. It does not contain the instructions of the function. But how does delegate reference the function? I want to use an analogy in this case. Imagine one day you go to a park and you see another person and you happen to talk to each other and you like each other and you became friends. But before you leave for the day, you want to remember each other's address so that you could go to the address and find the person and continue with the friendship. In the same way, a function has address and the delegate actually remembers the address. So under the hood, when a function is compiled into binary code and loaded into RAM, it stores as a block of binary code. Each line in the RAM has an address, just like this. And the delegate actually stores the beginning address of that block. In this case, it's 1024. Delegate is more than a function pointer that stores only the beginning address of the binary code block. It is more than that, but in this video, I just want to simplify it like this so that it's easier to understand. Okay, let's look at delegate in C# codes. So I have created a console application and also a simple add method which does nothing but add two integers together. And the syntax of writing delegate, and I can try to call the add function this way. But instead of doing it, I want to declare a delegate. So the way to declare a delegate is always to start with the keyword delegate. And then the return type of the function that you want the delegate to point to. And then the name of the delegate and the parameter of the functions that you want the delegate to point to. All right. So by declaring a delegate like this, we actually declared a variable type. We didn't declare a variable, we declared a variable type so that we can use this new variable type to create a variable, and we can use that variable to point to the functions. The function has to have this type of return value and these number of parameters with these types. So in this case, because the return type and the number of parameters and the parameter types are the same as the add function, in other words, the signature of the function is the same as this signature of the function, then the variable of this type can point to or can reference this function. So let me show you how to do it. So we can declare a variable. We can call it any name. I'll call it del here. And I just assign this to del. By doing this, the del variable actually points to the beginning address of the add method or the add function. And then when we call it, when we want to call the add function, we can simply do this. And then let's output the result to the screen. And let's run it and see the result. It's displayed on my other screen, and the result is 7. 1 plus 6 is 7. which is correct. So because we declared a delegate like this, which can point to any function with this type of signature, so we can test that out. What if I want to do multiply? Right? I can use del to point to multiply again. And when we do that, we can again call the function. This time we're expecting 6 because 1 times 6 equals 6. All right, so the first one is 7, which is 1 plus 6 equals 7. Second one is 1 times 6 equals 6. Okay, that's it. That's the syntax of delegate. It references the function that you assign it to. In this case, del reference the add function. The second case, del reference the multiply function. But what is the purpose of having a delegate? Why do we have to trigger the functions through the delegate instead of calling the functions directly? Let's look at the English word delegate. I think it's a much better word or phrase than function pointer in C or C++, because delegate, it means that you give work to someone else to finish instead of completing the work or the task yourself. So let's take a look at an analogy. Let's say, imagine you have a car that has a broken engine, and you take your car to your mechanic, and you want your mechanic to replace the engine for you. But you don't want your mechanic to go to any scrapyard because you know a scrapyard that has a lot of cars that is the same brand, the same model, and you happen to know the manager of that scrapyard. So you give your mechanic the name card of the manager of the scrapyard. Remember the analogy that we used just now? The name card has the address and other contact information to the manager of the scrapyard. So the mechanic can delegate the work of searching the engine, the proper model of the engine, to the manager of the scrapyard. He doesn't have to do that part himself. So let's look at how to use C# codes to implement that analogy, the car engine replacing analogy. So first, we need our mechanic. So we're going to create a mechanic class. And the mechanic will replace my engine. And I need to tell him about the brand and the model of the car. Perhaps the year as well, but I'm just going to omit that. So first here, we need to get the engine, right? And then the mechanic to replace the engine, and then done. So imagine the main function is myself, right? So I have a car and my engine is broken, so I want to call the replace engine. I want to ask the mechanic to replace the engine for me. So all I need to do is to declare a mechanic class, instantiate the mechanic class, and call the replacement engine with my brand and model. Right, that's it. But how does the mechanic get the engine? I don't want the mechanic to get the engine. I want the mechanic to ask the scrapyard manager to get the engine. So for that, I need another class, which is the scrapyard manager. And the scrapyard manager will help me to find the engine. Search. Again, the brand and model. And I also need a engine class. I'll just use an empty class. So here, imagine the manager goes into the scrapyard and find the engine. And I'll simplify it just like this. But I don't want to instantiate the scrapyard manager inside the mechanic because the mechanic can work with any scrapyard manager. I want to give the address of the scrapyard manager to the mechanic. And for that, we can have a delegate. Right? Well, I'm going to do a public delegate. And the return type of the delegate, which is the engine, because we want the delegate to be able to point to the search function. Right, so search delegate, and I'll just say condition. It doesn't have to be the same name. The parameter name doesn't have to be the same name as the parameter of the function that we want to point to. So here I have this. So the mechanic, in the mechanic class, we can have a delegate variable here. I'm going to say search delegate, and okay, search delegate. It's a property. So with the search delegate, we can call the search delegate like this, and then we replace our engine. You know, the mechanic will do some work here. I'll just use dot 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 to represent, and then here, when the mechanic done, the mechanic will say, I am done replacing the engine. So now we can, but we have to remember main represents myself. So I have to tell the mechanic about the scrapyard manager. So here I say mechanic search delegate equal to new scrapyard manager search. So what I'm doing now is to use the search delegate to reference to the search function inside the scrapyard manager. So then when I call mechanic replace engine, it will use the search delegate to find the engine. Right. So then this variable will be used inside here. And let's run the code. All right, so on the other screen, it says I'm done replacing the engine. Again, let's review. We have our mechanic here, and we tell our mechanic about the scrapyard engine, the scrapyard manager. And then the mechanic will just perform his own work. Here, the search, searching the engine of the car, this type of work is delegated to the scrapyard manager. That's it for the demo about implementing this analogy. Now let's look at another example that is more practical. So imagine we have a list of numbers and we want to find the numbers by a certain condition. And the condition can be passed in by using delegate. So let's create a class like this. So let's say we call it my list, and my list have is a list of numbers. Right? Instantiate the numbers like this. So I'll just give some random numbers. Yeah, whatever number we have, perhaps some smaller numbers, like this. And then we add the numbers to the list. Let's call add range. Add range. You can add the array into it. And here we want to find the numbers by a certain condition. But the conditions need to be passed in as a delegate. So we need a delegate here. Oops. Delegate, because it's a condition, so it's going to be boolean, and oops, and it's going to be like this. So then we can pass in the function by using a delegate. I just call it f to represent the function, and we will have a result of a list of integers. So now we're going to loop through the numbers, the list of numbers here. And we're going to use the function and say, if the current number satisfies the condition, which is provided by the delegate function, then results, add a number to the results. And then after the loop, we're going to return the results. So then to use it, we can just go to the main function, and we can instantiate the my list class. Oops. And we get the results. Equals list dot find numbers. So here we want to use a lambda expression. The lambda expression represents a function, and this function takes one parameter and returns a Boolean value. The type of the parameter is inferred. In this case, it's going to be an integer, and that satisfies the signature of our delegate. So it returns the results. So we're trying to say here is that give me all of the numbers that is greater than 100. And let's run it and see what happens here. So I'll take set a breakpoint here and I'll run it. All right. So the result in here, let's take a look at the quick watch window, and the result here is 344 to 122, all these numbers. If you look at the array that we provided here, there are 1, 2, 3, 4, and 5 numbers, right? 1, 2, 3, 4, 5. All of the numbers that are greater than 100 is listed in here. So that's correct. And by using the number expression, we can change the condition very quickly. So now we get the result again, and these are all of the numbers in the array that are smaller or less than 100. Another thing I want to show you guys is this approach that I just did is very, very similar to the link queries. Um, so I import the link namespace, and then let's see here if I do list numbers where you can see that this parameter is actually a delegate. This points to that needs to be pointing to a function that has one parameter, which is an integer, and returns a boolean. So I have the same here, right? The same type of delegate here, except that this delegate is declared by using generic, and I'm not using generics. So, and so you know, when you look at this, you know how the where method is implemented. It's actually very similar to this, except that I am not using um, iterators. The where method uses iterators and return a enumerable. In my case, I'm returning a list. Okay, that's everything I want to show you guys regarding Delegate. Hope this video is helpful, and let me know what you think. If you like it, please subscribe. Thank you.